Not sure. I think this was a question that we looked at, or something that I wanted to start with, which was evaluating functions. And then we looked at the absolute value. And we said the formal definition of the absolute value is when we are given the absolute value and we want to express it with no absolute value, then we have two options. One option is when x is positive or greater than or equal to 0, in other words, or 0, then there is no need. I can simply drop the absolute value symbols. But if this number is negative, if I want to drop the absolute value bars, then I have to write negative x. Because x is already negative, if I put a negative in front, this quantity will also be positive. Why did we need this? Well, for later, actually, because right now, what we're doing is we're solving equations with absolute value. And I'm not really going back to this situation, but this is what we're trying to do. We are using the formal definition, but I'm not telling you that we are using it. So how do we solve such an equation? Absolute value of x equals 3. We are asked to find all x values such that the distance between x and 0 is 3 units. So this is not scientific, but what I do is I ask myself, what numbers in absolute value will be 3? And the answer is two numbers, negative 3 and 3. And I wrote here that this is not a linear equation. So it cannot be treated as a linear equation. You cannot drop the absolute value symbols. So in general, if this p is greater than 0, then you have two options. Either x is p or x is negative p. Then we solved, based on what we just learned, we solved several absolute value equations. And we realized that there are actually 4 different possibilities. One possibility is when the equation has 2 solutions. When the equation has no solutions, like in this case, the absolute value equals a negative number. That's not possible. The absolute value is a distance, will always be a positive number. The right-hand side is negative. A positive cannot equal a negative. So no solutions. Then the third option is just one solution, and also infinitely many. So we had examples. This was an example in which we got only one solution. This was another example in which we had to clean it up. It was a little bit more extensive. And then we came to this example, this problem, in which it turns out that the first equation has one solution, but the second equation has infinitely many solutions. Since this number is included in infinitely many solutions, then we say that this equation has infinitely many solutions. And this is something else from my calculus class. That's it. So I would like us to start with an example from there, from 9.2, and then look at 9.3 and 9.4. So back to page, yes, I got it. Back to page 563. And let's say we start with problem 58, in which we have 8 plus the absolute value of 4m equals 24. So how will I solve this equation? What will be the first step? I have to subtract 8. Absolutely, it's not cleaned up yet. So this is 4m equals, when I subtract 8 from both sides, I get 16. At this point, I cannot do anything else but think in terms of 2 possibilities. So what are those possibilities? Very good. So there are 2 possibilities. Either the inside is 16 or the inside is negative 16. So from here, m equals 4, and from here, m equals negative 4. So solution, if you want to write as a solution set, I would write plus or minus 4 with braces. Let's also work on a problem, an equation with two absolute values, like 61, in which we have the absolute value of 2y minus 3 equals the absolute value of 9 minus 4y. Before we do that, let me ask you if you have any questions on the first problem, on 58. Any questions on the first problem? Okay, well, if you do come up with a question, please let me know. So what are the options for this particular situation in which the absolute value of 2y minus 3 equals the absolute value of 9 minus 4y? What are the options here? The opposite of 9 minus 4y. Very good. So notice that we cannot solve this. We can only replace it by these two equations. Don't cross it out like this, but I just want to make a point. I cannot solve that. But I can solve these two instead of this. The solutions of these two will make the solutions of this, which I cannot solve. But I can change it into two equivalent equations. So again, do whatever you want, but I will move 4y to this side and 3 to this side. When I move 4y, it's positive, so 6y. When I move 3, it becomes positive, so it's 12. So then y equals 2 from the first equation. Take a moment and let me know if you get the same thing. Now here I have to rewrite it. I have to distribute a negative sign first. So I have 2y minus 3 equals negative 9 plus 4y. That's what I have to do first. And now I move 4y and I move 3. When I move 4y, it becomes negative. So 2y minus 4y will be negative 2y. And when I move negative 3 to the other side, it becomes positive. Negative 9 plus 3 is negative 6. So then y equals 3. Let's take a moment and think about this and see if you have questions on this problem. Any questions? Okay, I would like you to work on 55 for a minute. 2x minus 5 over 3 in absolute value equals 7. Somewhat easier situation because it has only one absolute value. So 2x minus 5, everything over 3 in absolute value equals 7. And please tell me, what is the starting point? What are the possible options here? So please solve these two equations and tell me what you get. Yes, please.
For the top equation, I got x equals 13.
So x equals 13, and for the other one?
X equals
Negative 8. Did anyone get the same thing?
Yes.
Wonderful, excellent. So here I would cross multiply and get 2x minus 5 equals 21, or 2x equals 26, or x equals 13. I completely agree with 13. And on this one, I will get the same thing with 2 at the beginning, but negative 21. which means 2x equals negative, I'm sorry, 2x equals negative 16. Indeed, x equals negative 8. I agree with both. Perfect. Thank you. So I think that we've refreshed our memory on what's happening here. So now we can move on to 9.3. In 9.3, we will solve absolute value inequalities. Absolute value inequalities. For some reason, these inequalities confuse some of my students. Not sure why. I'm going to try to make it very, very clear, but for some reason, it's still somewhat confusing, and I blame it on myself, part of it anyway. So there are two possibilities, this possibility or this. I'm just giving an example, and then we'll talk about the general case, which is the same. So there are two options. The previous situation, in the previous section, we talked about this, which is an equation. Now we're talking about inequalities. There are two different things here. This one is more difficult than this one. This one says this to us. Find x values such that, this is supposed to be a quote, I'm sorry. Find x values such that the distance between x and 0 is, can anyone tell me what to write? Find x values such that the distance, which is the absolute value, the distance between x and 0 is, excellent, less than or equal to 3. How many numbers have the absolute? So let me read this again. Find x values such that the distance between x and 0 is less than or equal to 3 units. I should write 3 units for clarity. Units. Okay. How many numbers have the distance from 0 exactly 3? And for you, this is negative 3 and 3. These are two numbers whose distance from 0 is exactly 3. Now I have two options. Either these numbers have the distance between 0 and 3 less than or equal to 3 units, or those numbers. So two options. Option number 1. Option number 1 will be this, where I will find numbers whose distance from 0 is less than 3 units, or this, where will I find numbers whose distance from 0 is 3 units or less? Inside or outside? Do you all agree with inside? Okay, so then all I have to write is exactly what you just told me. Inside, in between negative 3 and 3. In interval notation, this will be this. And that is the easy one. Because I'm finding numbers between negative 3 and 3. Because these numbers have the distance from themselves and 0 less than 3 units. Or equal to 3 units. Now, this means the exact same thing, but when I get to less than or equal to, I will write greater than or equal to 3 units. So this is the same, except greater than or equal to 3 units. Bless you. So this is already occupied. We can no longer touch this. It's already taken. It's like a seat that was already taken. You cannot sit on it. It's taken by somebody else. Okay, so then how do I write the solution to this? So the absolute value of x greater than or equal to 3 cannot be written in a chain. This is nice. One chain. Easier. Here I have to write two different things. Can anyone tell us what to write? You have to express this to me, and you have to express this to me. That's all you have to say.
X is greater than or equal to 3,
Perfect.
and X is less than or equal to -3.
Perfect. So therefore, the solution for this is more complicated. -infinity, -3, union 3 to infinity. So that's why this is more difficult, because you have to separate the inequalities, and then you have to use the union symbol, for sure. No questions asked, or no doubt. Now I would like to practice. Say, any questions, please ask. Anything. Please. No, it didn't. To the right-hand side of 3, I have to write x greater than or equal to 3. To the left-hand side of -3, I have to write less than or equal to -3. However, you're right. If I were to solve the inequality changing the absolute value into x and then -x, the sign will change. But
So which one is the inside? Which one's the outside?
inside, outside.
No. Yeah. So like,
This is this.
Okay.
This is this. Good. So let's practice what we just saw on page 569. 569, I will start with 33 on 569. And we have the absolute value of x minus 3 less than 8. First thing we have to establish which type of inequality this is. There are only two types. There are only two types. So which one is it?
The easy one.
The easy one. Excellent. So then if it's the easy one, then you will tell me what to write right away. -8 less than x minus 3 less than. Very good. So in the past, for a few minutes ago, when we were looking for this, so the answer was -3 less than or equal to x less than or equal to 3. Now I have x minus 3. Therefore, -8 has to be less than or equal to x minus 3, or less than, I'm sorry, for without equal, and less than 8. What now? We had this on the test, right? So I will have to do what? To all three sides. So -5 less than x less than 11. So this is x in the interval -5, comma 11. If you don't write something in front of the parentheses, it may look like it's an ordered pair. So please write something, solution, or x in the interval, or something. Any questions? Any questions on this problem? Okay. So that's my page 3. What about 61? On the same page, 569. -15 plus the absolute value of 2x minus 7 less than or equal to -6. I cannot identify the type of inequality just yet because it's not cleaned up. What does that mean? What should I do? Yes, I have to add 15. So now it's 2x minus 7 less than or equal to +15 minus 6 is 9. Now I can identify it. And which type is it? Easy. So what do I write? -9. Exactly. In between -9 and 9. We know how to solve this. What will be the first step?
7.
Very good. So then I have -2 less than or equal to 2x less than or equal to 16. I'm adding 7 to all three sides. And the final step,
divide by 2.
Divide all three sides by 2. I have -1 less than or equal to x less than or equal to 8. And I write x in the interval. Can anyone read the interval for us? Excellent. Okay, now I would like to look at 75, which is the absolute value of 3x minus 5 plus 4. Oh, no, I don't want the equation. I want an inequality, so I'm going to change it. Sorry about that. So this is not 75. By mistake, I picked an equation instead of an inequality, so I had to change that. So it's not 75. It's something we just made up. I cannot identify the type because it's not cleaned up. By cleaning it up, meaning an expression in absolute value less than or equal to a number, or an expression in absolute value greater than or equal to a number. Nothing else can be attached to it. No terms, no multiplication, no products in front, nothing. It has to look like this or like that. So that's an expression, any expression in absolute value, either less than or equal to a number or greater than or equal to a number. I'm ready when you are. Sorry.
-4.
Yes. 3x minus 5 greater than or equal to 1. Now I can identify it. And I know for sure it's not the easy one. Therefore, this will change into 2 separate inequalities, which cannot be put in a chain. Don't even try. That would be incorrect. So what will you tell me to write first?
3x minus 5.
Say it again. I cannot write any equals. Greater than or equal to? If I say greater than or equal to -1, I'm including something that I'm not allowed to include. I cannot do that. It cannot be greater than or equal to -1. So, because if this is -1, greater than or equal to -1 will include something that I'm not allowed to include. So, greater than or equal to 1 to the right hand side of 1. Very good. What is the other option?
X minus 5 less than or equal to -1.
Very good. So it's either between -1 or 1, and that's not the case, or to the left, to your right, the right hand side of 1 and the left hand side of -1. Is that clear? Yes? Anyone? Okay. So now I have to solve the first one. How will I do that? Oh, well, I have to add 5 and divide by 3. So this is 3x greater than or equal to 6 or x greater than or equal to 2. In the same way, I have 3x less than or equal to -4. No, I'm sorry, it's +4 because I'm adding 5 minus 1, and less than or equal to 4/3. I already know from the beginning that the solution has to have the union. How do I write the union? You can say show me. So if that helps you, please graph it first. So if I were to graph it, I would do this. Greater than or equal to 2. This is 2. 4/3 is less than 2, is 1 and a little bit. So it's this line right here. And it's to the left. So this is 4/3. So if you want to see the graph, please graph it first and then write the solution. What will you tell me to write?
Would be parentheses negative, infinity, comma, 4/3 with the bracket, and then bracket 2, comma 2.
Absolutely. Okay. What about 81? Any questions for me? For some reason, at some point in time, this, I'm not sure why, and you should tell me if you can help me here, what is confusing? Because at some point in time, some students confuse these two types of inequalities. And if you tell me what's confusing, I may be able to present it better or correct your understanding if your understanding is not 100%. How will we be able to how could we let's say confuse the two or make a mistake here? Because
So that only can't go in the same file, it has to be like that.
yes, it has to be completely separate. It's to the right of 1, which has nothing to do with the left of -1, right? This one, it's always easier because it's just this number, whatever that is, must be in between. But you cannot write the same way here. And some students still try to write this by presenting something like this, which is incorrect. It's not possible. We cannot write something like this, and we cannot write something like this. It's either this or this. Okay? So 81, 3x minus 5, everything divided by 6 in absolute value greater than 5. Let's work on this for a minute, please. I don't have a date for test 2. But test 2 covers these 3 sections from chapter 9 and the entire chapter 7, which is huge. Okay, but I don't have a date for test 2 yet. Can anyone just get us started on this? Is it the easy one? If it's the easy one, then you have a chain.
No, it's hard.
It's the hard one. Yes, I agree. Which means we have to completely separate. Yes? This is the chain. This, with the absolute value greater than or equal to a number, is the outside.
Oh, so less than.
Yes, but you have to be careful. It's a very good question. You have to be careful where the absolute value is, because I could write it as 5 less than the absolute value. You still have to read it from right to left, because that may be confusing, right? So 5 less than this, you should always change it into the right direction. You should always change it to the absolute value greater than 5, so you don't make an error. So then, what are the options here then?
Would be 3x minus 5 over 6 is greater than 5, and then 3x minus 5 over 6 is less than -5.
Exactly. So it's nothing in between. The in between is always easier because they can be solved together. So I will solve the first one multiplying both sides by 6. So I have 3x minus 5 greater than 30. And then I have 3x, I move -5 greater than 35, so x greater than 35 over 3. I'll do the same thing with the second one. 3x minus 5 less than -30, and 3x less than -25, and x less than -25 over 3. I added 5 and I divided by 3. Knowing that it's not the easy one, then I know that I have to write the union. So x in the interval, you can graph it if you want before you decide how to write the solution. So what will I write? If you want me to graph it, I will. Do we all agree with this? Any questions? Is this okay? We understand the difference between these two? Okay. I have 3 more minutes. I'm just going to graph one inequality with 2 variables. So this is 9.4, which is not finished, of course. I just want to show you one example. Graphing or solving a linear inequality in two variables. Graphing or solving a linear inequality in two variables. For example, 2x minus 3y less than or equal to 6. I have actually no way of solving this inequality if I don't graph it. So that's why these two mean the same thing for an inequality in two variables. And you can say that's not true. When we graph a function, for example. When we solve an equation or inequality. True. But in the case of an inequality in two variables, they do mean the same thing. So here will be our first step. Write the equation. The corresponding equation to this. Oh, well, it's 2x minus 3y equals 6. Since it's a line, graph this line. In order to graph this line, I'm going to say when x is 0, and I'm going to cover it. How much is y? -2. What is the first ordered pair that I just determined? Very good. And then when y is 0, I'm going to cover it. How much is x? So what is the ordered pair that I just determined? Very good. So this is my second step. I graph the equation. So it's 3, 0, and 0, -2. Since there is an equal symbol here, I will graph the equation as a solid line. I will write somewhere, as we talked about a long time ago, 2x minus 3y equals 6. I did not graph the inequality. I only graphed the equation. And finally, in step 3, I pick 0, 0. Okay. So the origin is right here. In this territory, not in this territory, but in this territory. So this is the territory that I'm checking. So 0, 0. Is 0 less than or equal to 6? Is this true? So the area where the point that I used to get a true statement is the solution. Everything points on the line, and everything else makes 2x minus 3y less than or equal to 6. That is not the equation, but it's the inequality. If the answer would have been false, then I would have chosen the opposite territory, not the one that I checked. Because if this point doesn't work, no point will. Okay? So this is where we will continue from on Wednesday. So we'll have lots of examples and review chapter 9 and move on to chapter 10.